Hello everyone, today I make another video on Mastercam, and our topic today is how to verify stock in a multiple setup milling, or in other words is your multi-step milling. Okay, at first let's take a look on our part. Here I got a very simple part, and this part needs three three setup to finish. You can see here the first the first step we machine this face, and in the second step do a facing to cut to the desired thickness and do some chamfering here. And the third step or third setup, we need to cut a slot here and do the chamfer. So this is our part, and I will show you the setup. Okay, I have made three coordinate system. You can see here. You can see this is our operating sorry uh, coordinate system. Let's see. This is three. I got three vice. This vice for step one. This is for step two, and this vice is for step three. This just for information only. That you can see I have one, two, and three. I have create three coordinate system for every step, and I got here one, two, and three two pad curve for step one, step two, and step three. To save your time, I have created before. So this is our part in step one, and this part is step two. We need to claim and do the facing here, facing this surface. And in step three, we have clamp like this and mill this slot. Okay, I will turn the layer so you can see this is in this red area is the coordinate system, the first coordinate system. And here in the edge is the coordinate origin of the step through, and here I got the origin of the step 3. And one thing very important, that in Mastercam you have to uh, know the distance between this origin to this origin, and from this origin to this origin. And in this case I made this 400 millimeter. You can see here the distance is 400 millimeter. Sorry. Yes, that is very important. If you don't know the distance, it will be very difficult or impossible. All right. Why we need to verify stock like this? Because if you machine using only one solid, and you create coordinate system on this solid, you cannot verify the fixture, and it's very difficult to know if there's a collision. So this is a very good way to control the process. Okay, you can see here again, step 1 for this vice, step 2 for this vice, and step 3 for this vice. Okay, we begin with step 1. I do a stock setup here, already got the dimension, and in this case I use 16 millimeter thickness stock. Okay, you can see here the stock, the initial stock, and last I have created the tool pad already, and so we can verify the first step here. Okay, let's begin with verifying the first step. Sorry, my computer is quite slow. Yeah, you can see here we have 3 vice. At first we verify the first step. Let's do a quick view, so you can see that. So I will do a fast forward. Okay, and this is our first step. Let's turn on the workpiece so you can see it clear. And this is the part after the first step. You can see that. Okay, and the important thing is we have to save this stock, and then we use the save stock to use in step 2. Okay, let's save the stock. You click on file, save stock as, and select the location. Okay, so you can name it there because this stock is used for step 2. I name it step 2 stock. Okay, and click save. You can see that the stock will be saved as STL files. Click save. Okay, and step. Okay, after you have saved the stock for the step 2, and the next step we need to do is import that stock into our environment. To do that, you select file, file and pattern, and select the STL file you have saved. So you can see this is our STL file. So this is position location in step 1, and we need to move it to the right location, right position in step 2, because the stock is in STL format, so you can not do much with it. Just uh, calculate the distance and move and rotate to the right location. So before you move, you need to know, as I told you before, you need to know the distance between our two coordinate system. In this case, it's 400 millimeter. Okay, it will help you when you move. So we select the STL file, and I move it in by using dynamic form. So you can select a reference point. This here, the origin of step 1. I usually do this. And the first step, you need to flip it. That means you have to rotate it 180 degree. Okay. After you flip it, you move it in the Z direction and about equal to the thickness of the part, because in the step 2 the origin is set on the face. So this part is uh, 12 millimeter thickness, so I move 12 and okay. Next we need it to move in the X and Y direction. For the X we need to move a distance equal to the distance between two operation here. That's 400 millimeter. And because in this step the origin is set at the center, and in step 2 the origin moves to the edge of the part, so we need to subtract the distance between the center and the edge. So the total distance we have to move is equal to 400 subtract 50. Why 50? Because our my part is 100 millimeter long, so I move it 350 millimeter. That's the right value. Sorry, I move it in wrong direction. You have input minus 350. Okay, and our part is in right position in X direction, and the final direction is the Y direction. We have in the same manner we have to move distance equal to the distance between the part center and the edge of the part. My part is 50 millimeter wide, so I have to move a distance of 25 millimeter. Sorry, minus 25 for the right direction. Okay, done. And so you can see the stock is now in the right position. In step 2, that's what we need to do. Move the stock to the right position. That's very important. You have to calculate the value before you move. Okay, the next step, very important. You have to save this stock in the right position into another STL file, and we use that file for verify the step 2. Before you save this STL file, you have to turn on the layer off. Just keep this stock. Why? Because if you don't turn all the layer off, such as this device, when you save, all of the solid here will be saved to STL file, and we don't need it. It's not good. So the first I moved it to another layer, another level. Okay, is level 99. Okay, only one entity that's in stock, out of stock. You can move it to another layer, another level, and you turn on the layer off. Just keep the stock. I repeat, we need to keep the stock only. So now we can save it. Save it. You can save another in STL file. You can overwrite the old file you saved before, but it's better you save it in another name, such as step 2 stock right position. I think you should keep the original file because uh, if we have to make some change, you can use this file to make change, and you save this stock in the right position in another name, and this is what we use to verify in step 2. Okay, it's done. The stock has been saved, and we can delete this now and turn on a layer on. Okay, after we save it, we have to select that file, select that file for our simulation. Now move to step 2. This in the step 2 we have to facing to cut the remaining material and do some chamfer here, very simple. You move to step 2 and again move to stock setup. Now we need to select file, so Mastercam we use the STL file for stock setup. You can browse file here and select. Remember, you have to select your stock when it has moved to the right location. If you don't select it, this file is not work. Okay, you can select the step to stock right position file. You can select display to view it, preview it. Remember, the stock plane you need to keep is as top because you have moved the stock from step 1 to step 2. So if you don't let this top, uh, in this case top I use at the plane for step 1, so you should keep this value, not change it to any other plane, just keep it. So click OK, and you can see that this is our stock in step 2. That's what I want to talk about. Now we have the stock in right location, so we can verify it. You can next we can verify the step 2 with the right stock. Okay, select step 2 and verify it. So you can see here we got the stock, the right stock, and the picture. That's what we need to talk about. That's what we want, right? You can select the work piece and display stock only, and just do the verify. Okay, there is the facing. After the facing, we have this part you can see, and the chamfer. Very simple. Okay, so step 2 is done. We got the stock, the right stock has been verified, so we can control all of the cut. Okay, and we do the same as step 1. We save this stock to use in step 3. I will do is quick, so to save your time, another save stock, and rename this step 3 stock. Okay, after we save the stock for the step 3, we need to re-import it into our environment and move it to the right location by select file, bottom, and select step 3 stock we have saved before. So you can see the stock have been import here, and we have to move it to this location here by rotating and translating. like the same I did with the step 1 and 2. I have turned some layer up for easy work. Okay, now I can move it to the right location. Select the stock, dynamic, edge form, select the origin for reference point. First, I rotate it by an angle of 90 degree, and then I rotate it 180. As I know this distance is equal to 400, so I can calculate the right value of distance need to move. So I need to move here because our park length is 100 millimeter, so I move minus 300. Okay, now the x direction is right. I have to move in z direction because the width of park is 50, so I move 50. That seems right? Okay, the last direction is the y because the park thickness is 60 millimeter, so I move 16. Okay, I'm sorry, the thickness is 12, not 16, so I move back 4 millimeter. Okay, sorry, I move it 4. Move. Okay, the park is now in right position. Let's check it by displaying the park. Oh, I'm sorry, this not in the right location. We have to rotate it 180 to turn park off, and this toe needs to be in this side. So again, I move it. Let's do it quick. Okay, I'm sorry. 180. Okay, 80. And this direction, yeah, 100. Okay, let's check it now. That's right now. Okay, I'm sorry. So we got the stock in the right position, and save that. We need to save that stock in order to use it. Before you save, remember to turn on the layer off. We just keep uh, the stock only, so you can turn on the layer off and you keep the stock. Sorry, first I need to put this stock into a unique layer. Select it and change to layer 555 for example. So now I can keep. Okay, I keep this stock only, and now we save this stock to use. Save it, select STL foreign parasol stereo. Okay, stereo lithography, and select another name. Step 3 stock right position. Okay, let's go. After we save it, we can delete it and turn on the layer. Okay. After we save it, now move to the stock setup and select this file. Okay, we select the file you can see is the appear here. Step 3 stock right position. Just select it. Text OK. So you can see this is stock for step 3. The last thing is we can verify step 3 with our stock. So you can see this stock is taken from step 1, step 2, and now it's moved to step 3 for our simulation. Now let's do it. Just cut in the chamfer. Oh, sorry, some collision here. Maybe wrong chain having juice. I need to change it. Sorry. Okay, let's do it again. So this is the right operation. Yes, this is our finished part after the full simulation, and the stock have been verified from start to finish. Thank you for watching.